So this video is about building exponential functions. We've already learned how to build linear functions. We did that in the last unit, and this is actually pretty similar. So follow along, and hopefully it'll all make sense. Make sure you take good notes, write everything down, pause the video, rewind the video, do what you need to do. So let's start with an example. That's how I always like to start. And let's say we're solving a problem, and we've already made a table. We collected some data, we made a table. Very orderly, very neat. Great, there it is. So the next thing that we do, you should already know. What do we do after we have the table? We look for a pattern. So let's look for a pattern in this table. So I see the f of x values go 5, 15, 45, 135, 405, plus 10, plus 30, plus 90, plus 270. So there wasn't much there. Didn't really see a pattern there. So let's look for a different pattern. Times 3 also works. 5 times 3 is 15. Times 3 times 3 times 3. Great. We have times 3 over and over and over again. So we know that that's a pattern that might be useful to us. So now we read the pattern to show the work. What do we mean by that? Well, we start with 5, and then we see we have 5 times 3. So we'll put it there, 5 times 3. For the next one, we have 5 times 3 times 3. So we have that one. So 5 times 3 times 3, we put it there. 5 times 3 times 3 times 3, we put it there. And we could do that for the next one. We can keep going. So now we're starting to build the rule. We can see how this rule can be built. We have 5 followed by a bunch of 3's. So if we can find a shorter way to write that, things will get even easier for us. So 5 times 3 times 3 is just 5 times 3 squared. Right? Repeated multiplication is exponents, just like repeated addition was multiplication when we were looking at linear functions. Now when we're looking at exponential functions, we know repeated multiplication is our exponents. So here we have 3 3's, so it's 5 times 3 to the third power. Here there are 4 3's, so it's 5 times 3 to the fourth power. We can go back and fill in those other ones as well, right? This is just 5 times 3 to the first power. And here we have 5 times 3 to the 0 power. And be careful about that, 3 to the 0 power. In other words, we take 5 and we multiply it by 3 0 times, leaving us with just 5. 3 to the 0 power is not 0, it's actually 1. Why? Because when you don't multiply it by 3, it doesn't change. So now what? Well, now we can look for a relationship between what is changing in the work and how the x changes. So I see that when x is 3, the exponent was 2. The exponent is what's changing over here, so that's what I'm looking for a connection between, that x of 3 and the exponent, which is 2 here. The next one, x is 4, and the exponent is 3. When x is 5, the exponent is 4. So I see a pattern there, I see a connection, I see a relationship between the x values and the exponent in the work, which is what's changing. I see that the exponent is 1 less than our x value. Why? Because that tells us how many times we multiply by 3, and we didn't multiply by 3 when x was 1. So now we can try 100. We know it's going to be 5 times 3 times 3 a bunch of times. How many times? Well, remember what we said, that the relationship was that the exponent was 1 less than our x value. So if x is 100, we have 5 times 3 to 1 less than 100, or 5 times 3 to 100 minus 1, or 5 times 3 to 99. Then we can try x, and that gets us our rule. So again, we're going to have 5 followed by a bunch of 3's. But how many 3's? Well, 1 less than x, whatever x is. So how do we get 1 less than x? We just subtract 1 from x. So 5 times 3 to the x minus 1 power. So now we have our rule. F of x is equal to 5 times 3 to the x minus 1 power. Let's look at a slightly different example. So let's again say we've already made our table. We're looking for a pattern. Okay, we have 3 plus 4.2 plus 10.08 plus 24 point something. Oh man, there's nothing there. So we look for a different pattern. But I don't see one. I can't see another pattern. These numbers are so strange to me that I don't know what the pattern is, but I know what to look for. I know that if addition didn't work, then maybe I should try multiplication. I don't know if multiplication will work, but I should try it. So what do I multiply 3 by to get 7.2? How do you figure that out? What do you multiply 3 by to get 7.2? Well, you could keep guessing until you get the right answer, or you could just use division. So 7.2 divided by 3 is 2.4. In other words, 3 times 2.4 is 7.2. 17.28 divided by 7.2 is again 2.4. 41.472 divided by 7.28 again is 2.4. So we seem to have found a pattern. 3 times 2.4 is 7.2. 7.2 times 2.4 is 17.28. Times 2.4 for the next one, times 2.4 for the next one. You can go ahead and check it and see if that's right. Okay, great. So now we found our pattern. We're always multiplying by 2.4. So now we have to read the pattern to show the work. So first we start with 3, then 3 times 2.4, then 3 times 2.4 times 2.4, just like the last one now. So now it's exactly the same. We are multiplying by 2.4, which seems a little bit more difficult, but other than that, it's the same. So we can keep doing the same exact thing. 3 times 2.4 times 2.4 times 2.4, and of course this one. Now we look for that short way to write the work. We still have repeated multiplication, right? So 3 times 2.4 times 2.4, we can still use an exponent. 3 times 2.4 squared. 3 times 2.4 to the third. 3 times 2.4 to the fourth. So we can go back and look at those, and then we look for that relationship. It's the same relationship. When x was 3, our exponent was 2. When x was 4, the exponent was 3. When x was 5, the exponent was 4. So really it's the same pattern as we saw before between x and our exponent. So we can try 100, and we know we have a bunch of 2.4s. 3 times 2.4 times 2.4, etc. That leaves us with 3 times 2.4 to the 99th power, because 99 is 1 less than 100. Try it with x, a bunch of 2.4s. So 1 less than that, 3 times 2.4 to the x minus 1 power. So again, we have our rule. F of x is equal to 3 times 2.4 to the x minus 1 power. Make sure you've written all of this down. You're expected to know how to do this now. If you don't, please ask questions in class. Come for extra help if you need it.